Okay, so good morning, everyone, to this bootcamp session, Boost Your VMware Career with NSXT. The whole idea is very clear. The objective is very clear that think beyond vSphere and start thinking about what is NSX and what NSX is bringing us in this traditional networking world, right? So what are the topics we are going to probably discuss in this bootcamp session is that what are the challenges of traditional networking, right? See, the approach the GoVMlab always prefers is that first you try to understand why rather than jumping it that how do I do it? How do I configure NSX? If configuring the NSX is the objective, then trust me, there is no point learning the architecture and all those things, right? Because if the configuring the NSX segments, tier 1, tier 0 router and just running the traffic is the objective, then trust me, anyone can go and become NSX guy because it's just about the UI based stuff, right? But as a professional, we personally believe that at least GoVMlab really believe that we need to understand why and what rather than doing the how, right? And that's the whole idea in this particular session. First, we need to understand that why NSX itself, right? And that's the objective where we'll be making sure that you understand why NSX rather than how to configure NSX. Okay, so that's what it's all about it. So we'll be touching upon what are the challenges of traditional networking. That would be something we'll be discussing upon it. Then we'll understand what are the challenges with the traditional security solutions, what we have it in the market today. Then we'll talk about how NSX is actually solving those data center challenges. What is your VMware virtual cloud network? That's a VMware vision, virtual cloud network. Then we'll discuss about what are the key use cases of NSX data center. And then we'll briefly touch upon what is the NSXT architecture, what are the management component, management control plane, data planes in the NSXT architecture. And if time permits, I'll actually walk you through the NSX UI and try to see that how NSX itself looks like, right? Where do you actually go and manage the entire networking and security architecture or the notion of your entire software defined data center. So that's what pretty much we'll discuss in this particular bootcamp of NSXT. So now here we are going to touch upon that what is VMware virtual cloud network and what is this NSXT is all about it, right? Why there is so much of buzz in the NSXT. So now before we get started with the challenges of traditional networking, that is the very first question we should be asking to ourselves that does our traditional networking gives us flexibility of abstraction, pooling, and automation in the networking world. Now, when you really talk about abstraction, pooling, and automation, you have seen or you might have experienced these three terms in your vSphere world. When we talk about vSphere world, or when we talk about virtual machines, you might have created this abstraction because virtual machine is just an abstraction of your underlying physical hardware, right? When you do the pooling, the resource pooling, we do have a one physical ESXi server, and then basically we are just aggregating all the resources and then doing the resource allocation or resource sharing among these virtual machines, what we are running on top of that ESXi server. So that's the resource pooling, right? And then we do the automation. You can actually bring up your entire vSphere infrastructure just by writing those automation APIs or maybe using VRA or any automation solution. You can actually automate your virtual machine related stuff. So we have seen this abstraction, pooling, and automation capabilities in our computing world. And when we say computing world, we are talking about virtual machines. But the question here is, do we have the similar kind of capabilities, the abstraction, pooling, and automation in the networking world? Can I actually go and create logical switches, logical routers, firewalls, VPN, load balancer on fly? Can we do that? And the answer is no. We cannot do that in the networking world because networking world, we don't have those kind of capabilities. And that's the biggest challenge. What industry was having it with this traditional networking. Because when you really look at in your data center, see data center is not only about your virtual machines. Virtual machines are just one of the component of your data center. If you take any data center, let's forget about the virtual data center itself. Let's forget about the virtual data center. You just talk about, let's say, your physical data center. In physical data center, if you just have a physical servers, does that mean you will call it as a data center? No, because physical servers is just a one component of the data center, which is actually giving me compute, which is my CPU and memory. But with the CPU and memory, I cannot operate all of my data center operations. I really need to have a networking in place. I really need to have a storage in place. If I don't have storage and networking in place, what am I supposed to do with those physical servers, though they are giving me CPU and memory, right? So once you combine all of your compute, storage, and networking, they all come together and then give us this data center notion. And then once we have this data center deployed, then we run the applications on top of it. It could be a virtual data center, it could be a physical data center. But the point here is that when we're talking about the virtual data center perspective, the virtual machine is just have solved the one of the puzzle of this entire data center solution. The virtual machine has simplified the compute aspect of the data center. But what about the storage and networking? Until unless you don't virtualize your storage and networking, you cannot achieve that the solution virtual data center. What do we talk about it, right? So now we obviously, if we don't talk about vSAN and NSX, let's say we go back in 2011 or maybe early days of 2012 when there was no NSX and vSAN, yes, we were actually struggling with these two components. And because of these two components were not virtualized, we were still not able to get the exact benefit of this virtualized data center, though we have virtualized our physical servers into virtual machines. But with the introduction of vSAN and NSX, VMware solved the entire puzzle of this data center. And that is the reason today you can spawn up a data center within few hours, where it used to take few months. Actually, that's the optimization what has been gone through over the period of time, right? So now this particular slide says that there has been a lot of virtualization in the data center, and in last few years we have seen that, right? And why do we need a virtualization? Because we know the benefits of virtual machines, right? You can imagine, because all of you guys are coming from a vSphere background, and today if someone come and tell you that why do I need virtual machine, what benefit virtual machine is giving me, I hope you have answered to all these questions to your customers, right? But the point here is that it's all about virtual machines. What about storage and networking? And that is the reason the industry, this particular slide says that we do had a lot of virtualization in the compute and storage, but networking still had a bottleneck. And you know that the networking is one of the key pillar of any data center. Today, the classic example is just now look at that, 5 minutes, we had a session scheduled at 9 a.m. and 8:55, I was just trying to access my website and my website is not working. Though the website is being hosted on one server, that server was functional. The storage was there because my content was still there. But the problem is that I was not able to reach out to that particular website, which means the network communication was lost. If my network communication is lost, then what is the point of running your virtual machines and having your storage being there, right? Because at the end customer, if my workloads are not accessible to me as a customer, if my applications are not accessible to me, what is the point? It's a downtime for me, right? That is the reason networking always considered to be one of the key pillar of your data center. But the saddest part is that this one of the key pillar of your data center was not virtualized. And because it was not virtualized, it was imposing a lot of challenges to the enterprise customers to meet their business requirements. Because the lack of network virtualization was holding back our ability to keep up with the pace of business. Now, as enterprise customers, I really want to roll out the new features, new capabilities, new products in the market at much faster pace so that I can compete with my competitors, or maybe I can actually be the leader in the industry. But the problem is that this bottleneck was not allowing me to match up the pace of my business, right? The securing your data center security is one of the key concerns. Today, in this internet, the world of internet, you cannot keep your data, your personal data or your financial data on the servers which are not being secured. So security is one of the key aspects. And because we did not have virtualized solutions which can give this kind of security posture, we were still stuck up with the physical networking solutions. And then the cost of it, right? So there are a lot of challenges industry, the enterprise customers were really facing it out before this network virtualization came. Now, so let's try to understand some of those challenges basically, which I'm sure that as a vSphere administrator, you would have definitely faced it, right? Now, if you really look at in this particular diagram, what do we have it? In this particular diagram, if you really see that, we do have ESXi servers, right? So these are, so what do you see that in this particular diagram? You do have two vSphere cluster which are in separate racks on the separate VLANs. So, I mean, if you have ever implemented vSphere solution, right? You know that we always have it multiple racks, right? So one rack will be having a bunch of ESXi hosts, as you rightly see that, and all these ESXi hosts, which are part of one rack, will be part of single network, which is, let's say, VLAN 10 in our case. So this is our, let's say, rack 1, and this is our rack 2, right? Now all the physical servers which are in rack 1 are going to be part of same cluster. And obviously, because I want to have a seamless migration between these virtual machines which are running on the host part of all hosts are residing in a single rack. So obviously they have to be part of same L2 network, right? And that's where I've configured VLAN 10, where all these ESXi hosts are sharing the same network configuration, let's say VLAN 10. And there is a rack 2. There again, I have a bunch of ESXi hosts. These ESXi hosts again having a same network configuration, same L2 network, and they are configured with the VLAN ID is 20. So this is the rack 1 and this is the rack 2. This is how we actually go and do the implementation, right? And then we assure that there's a seamless migration between the VMs which are actually part of same rack, right? Because that's the whole idea of Vmotion, or that's the whole idea we use to design our vSphere infrastructure, considering the limitations what Vmotion really used to impose it, because of the L2 networking, right? So now this is what this slide talks about it. Now in this particular diagram, if you really see that, okay, from the L2 networking perspective, you have taken care of it, all these things, because they all sharing the same network configurations and the communication can happen between them. But what if this VM of the rack 1 wants to talk to the VM which is in rack 2? Because you cannot say that all of these VMs will be running in their own isolated rack. No, right? There could be a cases, and there would be, I mean, that's how you go and design your infrastructure. So obviously it could be the case that this is my rack 1 and this is the VM 1 in the rack 1 want to talk to VM 2 in the rack 2. In that case, what are you supposed to do? Because it's a VLAN 10 network and it's a VLAN 20 network. And we know that whenever we have a two workloads mapped to a two different networks, we need to have a layer 3 networking. If you don't implement layer 3 networking, the communication will not happen. And that is the reason, if you really see that all these racks, the rack 1 and rack 2 have been configured with your router, which is your layer 3 device. So the router is actually enabling communication between these two VLANs. That's a pretty standard what we know it. But is that a good enough that I just deploy a router between these two racks and that just enable communication between these two workloads which are running on these two racks? No, because that's what the problem you have solved it is the network connectivity. But what about security? And because to take care of the security, you install firewall at every rack level. So you install the firewall. Obviously it is going to be a physical firewall. So you will be installing physical firewall at every rack, so that when the workloads or as when your packet leaves out of this rack, it has to hit the firewall. The firewall will be doing the inspection, and after firewall doing the inspection, it will decide whether allow this packet to the router to forward to the next hop, or should I drop it. That's the whole idea of firewall. So obviously the packet has to be inspected by the firewall. We cannot allow lateral movement just assuming that every packet is trustworthy packet, right? That's not the way the data center is being deployed. So that's where you are going to deploy your firewall solutions at every rack level. And it's just a firewall. But if you really look at the production environment, you will not even have a firewall. You will have a IDS, IPS, and a lot of other physical devices to make sure the security posture of your data center is aligned with the company policies and compliances, right? And then what are the other things you are going to deploy? The load balancer, right? Because let's say you are actually, this is your web server, this is your Facebook server. Millions of users are actually hitting this web server. Then you cannot rely on only on a single virtual machine or single workload which is hosting all of your web requests. And that's where you are going to deploy the external load balancer, so that all the requests will be hitting this external load balancer. And this external load balancer will go and distribute the request among all of these virtual machine to distribute the load, right? That's the job of your load balancer. So you have to go and deploy load balancer also at every rack level. So this is how you actually go and build up your data center just to assure the requirement what you're having it right from the business perspective. So this is what this particular slide it's talking about it, that this is the posture that from the VMware perspective you might have taken care of this part where you have created a VMs, created some VLAN policies and port groups and all those things, right? But still, until unless you don't go and configure this part, your application will not be exposed to the end user, right? Because you have to take your physical networking team have to take care of this infrastructure part before making your application live or workload live. So now let's try to understand the problem here in this implementation. So it says that external firewall and load balancer used to access the workload, as I said. And then you have a traffic which is routed between cluster and to the external network. So as we have already discussed that whenever the traffic has to be routed, you require a L3 router in place, right? Now let's, and another thing it says that all of your VMs are assigning public IP or routable IP. The whole idea is all of these virtual machines, let's assume that they're having a public IPs, because if public IP, the whole idea of public IP is basically your external user can hit this public IP and actually get access to this particular server. So you know that the NAT concept and all of this public IP use cases basically, right? So now let's try to understand the problem here with this implementation or the current implementation, as you could see that. Now look at the problem statement here. What it says that there is a VM A, as you rightly see in this diagram, and there is a VM B. Now both of these VMs are running on same rack, right? So ultimately both of these workloads are running on rack 1. Another point to be considered here is that both of these workloads, VM A and VM B, is running on a same ESXi host. Let's assume it's your ESXi 1. So what we are considering here that both virtual machine A and virtual machine B, are running on same ESXi host, and they're also part of same rack. Now, if you really go with the vSphere networking concept or vSphere networking basics, right? If you really understand the vSphere networking basics, the vSphere networking basics says that if two VMs running on a same ESXi host, and let's assume that they are connected to a same virtual switch. If they are connected to a same virtual switch, the traffic will never ever leave that ESXi host. The traffic will be taken care by within that virtual switch itself, right? It not even will be going to the physical uplink. But now that is true enough from the layer 2 networking perspective, where from the VMware perspective, it's a good selling point that, okay, if you have a two virtual machine running on a same ESXi host and on a same virtual switch, the traffic will not leave the ESXi host, right? But is that something true from the production environment perspective? Have you ever seen the production environment, the real production environment where you are where both of these virtual machine on a same switch and you will not be sending this traffic to the outside world? If you have really seen this production environment, you won't find this use cases. The reason is that what if this VM is sending a malicious traffic? This VM is sending a malicious traffic. This VM is corrupted. Maybe this is my web server. Someone has downloaded the Trojan to it, and now the packet, the VM is corrupted. And because VM is corrupted, and this VM A and VM B both are connected to same virtual switch, I am not sending this packet to the physical world, because VMware is saying that two VMs connected to same virtual switch, let's forward the packet within switch itself, which means that all of your malicious traffic will be forwarded to this VM. And this could be, let's say, your database VM, database server. It will be done. And you could be have hundreds of virtual machine connected to same virtual switch. Then all of these virtual machine will be corrupted, will be impacted and compromised. Down, your data center will be down. So do you really think that this is what industry does it? That if two VMs connected to same virtual switch, let's have this lateral movement of the traffic, and let's not forward the traffic to the physical world. If you're not really concerned about security posture of your data center, and if you're just running your test workloads, it's fine, because test workloads, you assume that none of the person of my team or my company is going to download some malicious traffic, right? But if it's a public server or whatever it is, basically, right? If one of the VM in that particular networking posture is vulnerable, then trust me, all of your VMs are going to get impacted. The reason is that VMware doesn't have an intelligence or the vSphere product doesn't have an intelligence to figure it out that this VM is sending a malicious traffic. What they really care about is this is the L2 packet is coming. What is the source? What is the destination? What is source MAC? What is destination MAC? This is what I care about it. And if the destination MAC is connected to the same virtual switch, I will not send it to the physical NIC. I will directly forward the packet to the another VM which is connected to my another port. Done. And this is the exact problem what industry was having it. That how could I trust this virtual machine? Because VMware is not giving me any security solution. And I don't trust this VM. I want every packet to be inspected before sending this packet to the another virtual machine running on a same virtual switch of the same ESXi host. I don't care. That is the reason what industry used to do. You used to have this external firewall, which is a very expensive firewall devices. Why do you think they are like Juniper firewall, Palo Alto firewall, where they are making a business? They are making the business here only because they are the expert in the firewall solutions, right? And they have an intelligence to detect those malicious packet. So now what industry used to do, though you have virtualized your physical servers into virtual machines, you have to have the implementation of this physical firewall solution so that if the packet is coming from a VM connected to a same virtual switch, I don't care. I will send this packet to the outside world so that this packet hit my physical firewall. My physical firewall will be doing all that inspection. After doing that inspection, if it's a malicious traffic, the packet will be dropped here itself. If it's not a malicious traffic, then the packet will again come back and then it will be delivered to your virtual machine. This is how you actually go and deploy the solutions end to end in your infrastructure, any production environment, right? So now the problem, what do you see that in this particular posture, that imagine a scenario where you have hundreds of virtual machine. Just imagine a scenario that you have all these virtual machine connected to a same virtual switch. Just for the moment, just assume that all of these virtual machines are connected to a same virtual switch and they all running on a same ESXi host. All of these virtual machine running on a same virtual switch, running on a same ESXi host, but still you want every single packet to be traversed over the physical network. And then the inspection has to be done. This is the optimization. This is the inefficiency in your implementation. This is the biggest problem what the VMware customers were having it. They say that you have virtualized your physical servers into virtual machines, but still that is not the answer to every single problem of ours because your solution is not end-to-end done. It is not solving the exact challenges. What maybe I had 100% challenges earlier with your virtual machine, you might have reduced that challenges 30% challenges you might have reduced by virtualizing the physical servers, but we are still struggling with this 70% issues. Until unless you don't go and optimize these 70% challenges for us, how we will be in the market and doing a lot of innovations and then bringing our products into the market and optimizing the things, right? It was not possible. So now this particular problem statement, we call it as a hairpinning. In the networking world, this particular problem statement, you call it as a hairpinning. Hairpinning means though you have a distributed workloads, distributed across multiple ESXi host or maybe same ESXi host, whatever you want to call it off. But though your workloads are distributed, still you are creating a bottleneck by implementation of this hairpinning, where all the traffic is again pointing to a one single device, and then the inspection is happening, and again it's being reverted back, right? So this is the hairpinning is the classic problem in your physical networking world, and that is the reason it introduced a lot of inefficiency in your data center operations. So that's the first problem. The second problem, what happened is basically in this particular diagram. If you really see that, let's say if this VM wants to talk to another VM which is in a different network, right? So VLAN 10 to VLAN 20. So I'll just try to give you another scenario. I mean, this scenario could be you won't be able to understand it, but let me give you another scenario. Just assume that as of a moment, just assume that this virtual machine is part of VLAN 10 port group. So what you did, you created a one port group and assigned a VLAN ID as 10. This virtual machine is actually part of VLAN 20 network. Okay, we usually, from the vSphere perspective, we don't go and design the networking this particular way, but I'm just giving the flexibility where rather than segregating this workload at the rack level, let's assume that what you did, the VM A, you actually configured with the VLAN ID 10, and VLAN B is actually configured with the VLAN ID 20, which means that let's say this is my 192.168.10.x network, and this is my 192.168.20.x network. So these are two different network. What are we supposed to do to enable communication between them? Can vSphere solve this problem? vSphere cannot solve this problem. It just give you L2 switching. Then what you need to do, you need to send this packet to the router, which will again, what is going to happen? Again, you have a virtual machine running on a same ESXi host, right? Maybe connected to a different virtual switches, whatever you want to call it off, but still you have to send every packet to this physical router. This router will do the inspection and again packet will be delivered. So again, you are doing the hairpinning at the routing level. So again, you are doing the hairpinning at the routing level because for all this L3 networking, you have a dependency on that centralized router which you have deployed right here. This is again a classic example of hairpinning. And now imagine a scenario, the hairpinning was not a problem in your physical world. Physical networking world, there was no concept of hairpinning. The reason there was no concept of hairpinning, because if you really see the physical networking, the things were way simplified. Because in the physical networking, what used to happen is basically, if I just try to draw it down, let's say this is my Windows system. This is another Windows system. Or maybe this is my Linux system, for example, right? These were my physical servers. Now, every physical server will have a physical NIC. This physical NIC, I was actually connecting to my physical switch, right? So let's say this is my one physical switch. This is my another physical switch. This is my another physical switch for the simplification, right? So now there is no traffic which is running inside the system itself, right? Because it's a dedicated servers. So if this Windows server wants to talk to this Windows server, the packet has to go to their adapter to the physical switch. And if they are actually a part of three different network, right? If they are actually part of three different network, let's say VLAN 10, VLAN 20, VLAN 30. Even if they're part of three different network, we know that if we want to enable this communication, the packet has to go to the physical switch, and this physical switch will be connected to some centralized router. So every packet coming from this Windows system will hit its adapter, go to the physical switch. Then physical switch will say that I will send it to my default gateway. The gateway say that, okay, this is the router interface. I have to route this packet, and the packet will be delivered here, right? So every packet is being inspected here. But in the virtual world, the equation has completely changed. Because in the virtual world, what is happening is now instead of this Windows system, whatever we discussed just now, just imagine this Windows system replaced by ESXi, ESXi 1, ESXi 2, and ESXi 3. Now everything remains the same. Everything remains the same where we have a physical uplink and then we have this physical switch, right? So this is again your physical uplink, what you have it, which is you call PNIC or whatever we want to call it off, right? So this is my again a PNIC, and then this is my again a physical switch to this is again a PNIC of another server, and this is my physical switch, right? This is what we used to have it. But the point here is, and let's assume that all of these ESXi hosts are part of three different networks. Let's say VLAN 10, VLAN 20, and VLAN 30. And most important thing that usually, if you really see that, we will never create this VLAN network at every ESXi host level. So for this particular discussion, assume that whatever workloads you are running in your ESXi host, right? So let's say this is my virtual machine, but I'm running it here. This is my virtual machine, what I'm running it here. And this is my virtual machine, what I'm running it here. Now, if you really understand this virtual world, the virtual world, what is happening is if this VM it's want to talk to this VM, or if this VM is trying to talk to this VM, the packet is not going to hit your physical NIC. If packet is not hitting my physical NIC, then I don't have a visibility about that traffic. So the point here is that as when your distributed, as when you started deploying more and more virtual machines, the visibility of the traffic between this virtual machine was less because the lot of traffic was not going on that physical network. And until unless if the traffic is not going on the physical network, how will I have a visibility on my traffic which is flowing within my virtual machine? The second problem is that because of this east-west traffic, right? Because of this virtualization or because of this virtual machines, your traffic pattern has completely changed. In the Windows, in the previous physical world example, if you really understand that, this is my Windows system and this is my physical switch, right? So my traffic is flowing in this direction, which is, we call it as a north-south direction. But in the virtual world, what is happening, because this Windows system has virtualized as a virtual machine, so traffics are flowing in this direction. So this is what we call east-west traffic. So the pattern itself has changed because of the emergence of virtual machine. I know that you are not coming from that deeper level of networking background, but just try to understand from the vSphere knowledge also that as when you started deploying virtual machines on a single ESXi host, your traffic pattern is completely changed from the physical world. The physical world, the traffic used to be flow from Windows to physical switch. It's like a north-south traffic. But then in this particular virtualized world, the traffic flow has changed and your traffic is going through the east-west traffic, right? The flow itself has changed. And because that east-west traffic is keep increasing over the period of day, it becomes a bigger concern for the industry or the enterprise customer that how do I get the visibility into my traffic? What if I don't know this? I don't trust these VMs, right? And that's where we are getting into this hairpinning issue. And that is the reason this particular slide says that inefficient routing has become a bigger concern as when the east-west traffic was increasing. Though you have virtualized your multiple physical servers into though you have virtualized your hundreds of physical servers into this virtual machine, but still for the routing you are depending on the centralized router, and then your traffic is getting pinned to a one centralized router in the traditional networking. That's the first problem. The second problem statement with the traditional networking, if you really see that, right, just assume it that this is the VMA which you are trying to migrate to, let's say, this host. So let's say this VM is running on ESXi 1 and you are trying to migrate this VM to ESXi 3. Do you see any issues in this implementation? I don't see any issue with this implementation because this is what we have been keep doing for the decades. When VMware introduced Vmotion, this is what we are keep doing from the decades, where to enable this seamless migration, what we are doing, we are keeping all these ESXi hosts into a same L2 network, so that I can enable seamless migration, because no network IP is getting changed, no network posture is getting changed, and in fact no change in the firewall also, because this firewall is actually being taking care of this entire rack system. So it's fine even if this VM migrating it here, this firewall can inspect the rule, and there is no change in require in your firewall posture, right? So till this point it's fine. But the question here is that what if I want to migrate this VM from this cluster to this cluster? So let's say this VM is actually running in rack 1 and I want to migrate this VM to the cluster which is actually part of rack 2 and configured with the VLAN 20. Now how would you do that? Because this, if you really understand, I hope you understand Vmotion. So if you really understand Vmotion, we are not reconfiguring the IP addresses of that virtual machine, because there is not even a one single TCP packet is being dropped, right? Not even one packet is being dropped. Not even the TCP session is getting terminated, right? But the point here is that if you're trying to migrate a VM from cluster 1, which is a rack 1, to the cluster 2, which is in rack 2, and the most important thing is this is the VLAN 10 network, this is the VLAN 20 network. And if I just try to simplify it more for you, let's say this VM VLAN 10, let's say having a IP address as 192.168.10.x, and this is having a IP address 192.168.20.x network. So now let's assume this VM was actually having an IP address 192.168.10.11, for example. But then when you migrate this VM to this particular network, obviously it's a vMotion, which means it will be having an IP address same 192.168.10.11. Do you think 10.11 can talk to 20.x workloads which are running on this particular cluster? No. Then this is not a vMotion. The moment VM will come here, it will lose the connectivity, because this network is only allowing the VLAN 20 traffic. That's the problem. So then what you will do? what you have to do, you have to reconfigure the IP address of this virtual machine. And that is not the vMotion then. Because if you're migrating this VM here as a, let's say, cold vMotion, whatever you want to call it off, or even if we don't call it as a live migration because the VM loses the connectivity. So ideally it's a cold migration only. And then to enable this VM to communicate with its peer workloads, you have to reconfigure this IP. Now, once you reconfigure this IP, this firewall posture will change, because this firewall was inspecting this virtual machine bind with this IP address. But the moment you change the IP address from 10.11 to 20.11, this firewall, whatever rule it had it for this particular virtual machine, that rule will become a stale rule, obsolete, because that entity does not exist anymore. But the firewall is not aware of it. Firewall will say that there is an entry for 10.11 IP. So I'll be looking for 10.11 IP, but we know that there is no 10.11 IP exist anymore because that VM has got migrated to the different cluster, has been reconfigured with the new IP, which is 20.11. And this firewall will not have any security posture for 20.11. All right. Because this firewall doesn't have any posture for 20.11, and you as a security admin or any network admin security admin does not go and update the firewall rule, you are putting your data center into I mean, you are exposing your data center to the attacks, because maybe someone is getting access to this particular IP address, and because the firewall doesn't have entry for this particular IP address, he can have a lateral movement. He can attack. This VM can be compromised. He can use this VM for the attacks, and then he can have a lateral movement in your data center, right? It can have a lateral movement in a data center, and the data center is compromised. So that is the problem I was trying to explain you. The problem, what I was trying to explain you here is that you really need to, you just migrating a VM, not even migration, cold migrating a VM, changing the IP address does not solve your problem. Until unless you work with your network team or security team and make sure that the right firewall posture has been enabled for this new workload, what is being hosted here. And that's where we have a dependency, because vSphere team have to keep in touch with the network or security team to make sure that this VM can be accessible to the outside world only once the firewall rule has been created. And second thing, you also need to talk to your network team to make sure that and tell them that this firewall rule, what you have enabled for 10.11 IP, please go and delete it, because that rule is a stale rule now. And if you don't work with your security team to delete those stale rules, imagine it's just an example of one VM. What if your DRS or maybe someone else is keep migrating your script is keep migrating a VM in this kind of environments? Hundreds of migrations are happening. I won't call it as a live migration, but just try to assume that your VMs are being moved from one host to another host. And in that case, just imagine if hundreds of VMs are every day, you are moving it from one cluster to another cluster. Then look at the complexity you really need to deal with from the security perspective, and in fact, the networking perspective also. That's a challenge what the networking teams were really having it in those days, right? So this is, so now you can imagine that how complicated it is. Just deploying a VM and then just assigning vCPU and memory to that VM and installing some operating system to that VM doesn't solve the problem from the data center perspective. Your application or whatever you see, ultimately it's not VM what the customer is going to use it. The customer is going to use the application which is running inside that VM, and this application will be accessible to the customer only once your entire VM is ready, right? And when I say entire VM is ready, which means that not only its CPU and memory construct, but its networking and security posture and networking security and storage posture also has to be in a line, right? That is the reason the industry was struggling, though they deployed these virtual machines. That's another problem. So this is what this particular slide says, that the moment when you migrate a VM, there will be change in IP. Now, when there will be change in IP, this firewall is not aware of it. So that's a problem, right? So have you ever wanted to move a workload but could not because it was pinned to an external firewall or load balancer on the network? So what this slide is actually saying, that that is the reason a lot of people don't understand the use case of NSX. See, that is the reason you always have those restrictions where you had to make sure that whenever you design your vSphere infrastructure, keep your all the workloads, all the ESXi hosts within a same network only. And that is the reason we always used to keep them into single rack. so that I can have a seamless migration and I don't need to make any changes in my load balancer and firewall posture. But you're always struggling to migrate these workloads from one cluster to another cluster. And today also in the vSphere networking, find out a way that how could you migrate a VM from one cluster to another cluster, which are part of two different racks and two different VLAN based network. Try to find out the answer of this problem and you will get to know that the challenges, what it imposes, right? And that is the reason we used to design our infrastructure like that. So that's what this particular point is all about it. And that's what this particular slide says, that though VMware has given you the compute virtualization, which is your ESXi hypervisor. So though VMware has given you this compute virtualization as an abstraction layer where you could decouple your physical hardware into the virtual machine, but still the virtual machine has a dependency on the underlying physical networking infrastructure. So you still have a dependency, and this is what this particular diagram says, that there is a tight coupling between your virtual machines and the underlying physical infrastructure. And because of this tight coupling, the provisioning of the workloads was very slow, right? What do you mean by provisioning of the workload is very slow? Now, today, if you really see that, let's say you are the one who is actually managing the VMware infrastructure for your company. I am a customer of it. I'm a user. I say that I really need a one virtual machine with this configurations, and I really need it available within 1 hour because there's a some workloads I really need to test it from the end user perspective, right? Can you give me a VM within 1 hour, where it could be the case that you already have a template of that VM. You already have a template with all the patches, all the software installed in it. So within 5 or 10 minutes, you can get that VM ready, right? But you cannot keep this VM available to your end user within this 10 minutes. There is no way. Because though you could deploy and get that VM up and ready within 10 minutes, but you really need to get the approval from your network team to have the right security posture enabled, to have a right VLAN configured, routing posture configured. And once your networking security teams gives you go ahead, after making sure that the VM is following all the company policies, compliance rules, everything, and then you will be making that VM available to your end customer. So the point here is that deploying a VM might taking 10 minutes for you, but making that VM available to end user might take 2 or 3 hours for you. That's the problem. That is the exact problem. What we were actually facing it out in early those days, right? So provisioning is slow. The placement is limited. I cannot migrate my VM randomly from here to there. If I have to migrate a VM, I really need to make sure that my source and destination host is a part of same L2 network. If they are not part of same L2 network, I cannot seamlessly migrate my VMs from one cluster to another cluster, which are two part of two different network, which means that the mobility is limited. The migration, the placement was limited, right? And that's what this particular point is all about. It mobility is limited. You always have to configure your VMs within that same cluster or same rack. The hardware dependent. Your workloads, your virtual machine configuration is completely dependent on your underlying hardware. Whether if you have a Cisco hardware, the things are different. You have a Juniper hardware, the ways are different. The way to configure the things are different. You have a Palo Alto hardware, things are different. Arista hardware, things are different, right? So your security posture, networking posture is completely dependent what vendor devices you're using it. And whatever features that vendor is giving you, you have to be limited with those features and those skill set, right? That's the problem. Operationally, way intensive. It's not that easy. Today, just imagine, try to understand this problem. Like, see, just imagine if you in your data center, you have a hardware coming from a different vendor, HP, Dell, Lenovo, or maybe IBM, all these vendor hardware is there. And tomorrow, and just imagine VMware does not have this vCenter UI, where with the one UI, you can manage all of your virtual machine workloads without caring about what is my underlying hardware. I don't care about whether it's a HP server, whether it's a Dell server, whether it's IBM server, because VMware has created an abstraction layer, which is ESXi. So I am managing ESXi, which is a common across all these different vendors, right? So it gives you a very simplified interface through which you can manage your entire infrastructure in a much more easiest and efficient way. But imagine there is no vCenter server, there is no ESXi layer, and then you have to manage your servers for the Dell, HP, and IBM. Then how do you go to manage it? You used to manage these servers from their ILO interfaces. HP will have its own ILO. IBM will have its own ID rack and all those things, right? Complicated. Just try to imagine the problem that how the world used to be when we didn't have this vCenter kind of stuff, right? Then there are hundreds of servers coming from different vendor. Every time you are switching between the different ILO consoles of the servers just to manage your servers. Same problem lies in your networking also. Today, if I'm using a Cisco hardware, Juniper hardware, maybe my Palo Alto hardware, all those things, do you think that all these networking vendors is giving you some centralized interface through which you can manage all of this vendor hardware? No way. They are competitors, right? So that is where just imagine the world that though VMware has simplified the things for you from the server management perspective, but from the networking or security perspective, you are still going to deal with this vendor complexity. For the Cisco switching, you have to log into the Cisco device, Cisco UI or Cisco CLIs. Then you for the Palo Alto security, you need to log into the Palo Alto UI when understanding their security commands, right? So way complicated. That's what this point is all about. It's operationally way intensive. Asking is for industry saying that you know we really need to meet the demand of a dynamic business environment. The industry says that the enterprise customer says that our today's traditional data center, even after deploying the virtual machine, is not solving the purpose. Today, in this competitive world where we have to roll out the feature every week or every 2 weeks, we need to launch our app. We cannot do that if we have this kind of rigid infrastructure. We really need to we really need to pace up our business, and we really need to make our IT operations more agile and flexible. And we also need to deliver networking and security way faster than cyber criminals, right? We really want a flexibility, a mobility, a visibility. We really want flexibility, mobility, visibility in our entire data center from a single pane of glass. We cannot want to juggle up between n number of dependencies. Cisco guy doesn't understand Juniper solution. Juniper guy doesn't understand Palo Alto solution. Then you again getting into dependencies, and then increasing a lot of complications, right? And that's where what needs to be happen. So the point here is that what needs to be happen. The customer says that we want the operation model same as virtual machine. The customer says that VMware. The customer says that hey VMware, whatever the solution you have given to us from the virtual machine perspective, where we could decouple our virtual machine from the hardware. We could actually create, delete virtual machine. We could grow our virtual machine. We could shrink our virtual machine on fly without causing any downtime, without having any dependency on the physical infrastructure, right? You have given us a virtual machine as a solution where we can programmatically deploy the virtual machine. We can just fire the API, write the code, and our virtual machine will be deployed. We need the similar kind of notion for our virtual network also. Can you give us a solution? Can you give us a solution where we can run the network? We can run the network same like virtual machines. Can you give us something like that? Where we can grow the network, we can create the network, we can delete the networks on fly. We can program end-to-end networking and security posture just by firing through APIs, or maybe automating some, writing some code and then automating the end-to-end posture of my data center. Can we do something like that? And the answer to all this solution is NSX. Okay, so answer to all these solutions where you want to decouple the hardware, where you want to deploy your networking on fly in a consistent way, and you want to automate your end-to-end networking operations. Answer to all of this question is VMware NSX. NSX is the only solution in the market today which solves all of those challenges what we have discussed so far. And that is what NSX is all about it. So what is NSX? If you really understand the NSX, it is another hypervisor. Okay, similarly, when you have your ESXi hypervisor, right? So you used to deploy ESXi hypervisor, and that is used to decouple your underlying hardware from your virtual machines. That's what the NSX is doing it, where NSX is decoupled all of your networking hardware capabilities, and it virtualize all of the networking capabilities into software. So you do see that there is a firewall, there is a load balancer, there is a VPN capability, routing capability, switching capability. All these capabilities are available, which used to be there in the physical devices. But now, because of the NSX, all these capabilities are available in the software. And this software is what? This is your NSX. So now NSX gives you logical firewall, logical load balancer, logical VPN, logical switching, logical router. Why logical? Because this router is not something which you can see it, which you can feel it. This switch is not something which you can see it, which you can feel it, like your physical networking. In physical networking, you can always see your router, you can always see your switches, firewall, VPN devices. But in the NSX world, it's a virtualized solution. It gives you same capabilities or more capabilities than what these physical devices can provide to you. But these are all logical entities because these are not physical entities. These are just a kernel modules which is giving you routing switching capabilities. That's what NSX is all about it. And on top of this NSX, you can integrate any cloud management platform. For example, your VRA. So your VRA is tightly integrated with vSphere, where you can create those blueprints and automate every virtual machine stuff. Similarly, NSX is also integrated with the VRA. So now with the VRA, you can integrate your NSX and then you can actually deploy your virtual networks on fly. And then your application is right there. So this is what your NSX is all about it. So that's what this particular slide says, that what is NSX? NSX is a network virtualization platform that you can use to build a rich set of logical networking and security services in the SDDC. NSX is the industry leading network virtualization and security solution for SDDC. NSX delivers for networking the capabilities VMware already provided for compute and storage. So what VMware has already done for the compute and storage by giving vSphere and vSAN, NSX is doing the same thing for the networking and security. Because of this NSX, now your virtual networks can be created, can be saved, delete, and restore on demand without doing any changes in your physical network. That is the power of NSX, where once you do the physical networking configuration, after that, you can create, delete your NSX networks on fly without making any changes on the physical networking. So it's like do it once, deploy your networking once, and then create your NSX networks on fly as many times as you want it. That's the power of NSX. So if you really see that, this is the classic comparison between your ESXi hypervisor and NSX hypervisor. In ESXi, you had this physical server where you actually deploy this hypervisor layer, and after deploying your ESXi hypervisor layer, you could create virtual machines out of it, right? Similarly, so your hypervisor is decoupled. It has done the decoupling from your underlying hardware to the software. This is what your network hypervisor is doing it, which is your NSX. So now you have your physical switches, but now you have taken out all the intelligence from the physical switches, and now you have put all these services right there into software, which is your NSX. And then you are creating this virtual network, same like your virtual machines on fly. So this is what we call it as a network hypervisor. This is your server hypervisor. This is your network hypervisor. And it is also doing the decoupling, creating the abstraction layer. And then it is giving us all of this switching, routing, firewall capabilities, what we used to get it from the physical server, physical devices. Now we are getting all these capabilities from the NSX software itself, hypervisor itself. And everything is available in the software space, logical space. So that's what it's all about it. And now that's the benefit what this NSX gives you because of this introduction to this network virtualization. Your provisioning becomes faster. You can actually do the programmatic provisioning because it's a complete solution, same like your virtual machine. The way you automate your virtual machine related stuff, now you can automate entire networking and security stuff for your virtual machine. So the moment you power on your virtual machine, it will not only have your operating system patches, whatever you have done it from the template, but now it will have the right networking policies to be configured, right security policies to be configured there itself. Placement is limited. No. Now you can place your workload anywhere. Your VM is running on one cluster and you want to migrate it to another cluster, having a different networking posture, it's all fine. Because of this NSX, now you can migrate your VM from rack 1 to rack 2 without reconfiguring its IP address, what we have discussed in the problem statement earlier. You do not need to reconfigure your virtual machine IP, though your clusters are part of two different networks. You do not need to reconfigure the firewall rule where you need to add a new rule to the rack 2 firewall and delete the older rule from the rack 1 firewall. You don't need to do it. As when your VM gets migrated, its security posture also migrate along with that VM. That is the power of NSX. The mobility is limited. No. That is also ruled out because now you can move your workload anywhere. And that is the reason, if you know that the VMware Cloud on AWS solution is a classic example of NSX. Today, you can migrate, forget about cluster 1 to cluster 2. You can migrate your VM without any downtime from on-prem data center to VMware Cloud data center. And you can imagine on-prem data center and VMware Cloud data center are two different worlds, right? But now, because of this NSX, you can migrate your virtual machine without any downtime, without any reconfiguration. You can migrate your VM from on-prem to cloud. That is only possible because of NSX. Hardware dependency is also decoupled. So now there is no hardware dependency. No matter you have a Cisco hardware, Juniper hardware, Palo Alto hardware, doesn't really matter. We don't care about it because in fact, we don't need those hardware at all because now the intelligence is right there into software. So you just give us any general purpose hardware, will make it intelligent because of NSX. And operationally intensive, that is also ruled out because now you do not need to deal with n number of vendor devices. It's a one platform which is not only giving you networking but also security solution also it's giving you. So one NSX platform will give you everything. So you don't need to juggle between n number of vendors and n number of UIs and then having a different kind of expertise. Or everything got simplified because this is a one single solution, one single platform which gives you single pane of glass where you can have end-to-end visibility of your data center. And in fact, it gives you more than what your physical infrastructure can gives you. And that is only possible because of NSX. So if you really try to understand that what NSX consists of, so if you really understand what NSX consists of, NSX is having a switching. It gives you switching, it gives you routing, it gives you load balancing. It also gives you a way where you can connect your virtual machine workloads to your physical networks. It also gives you amazing firewall capabilities, VPN, data security, and end-to-end monitoring. So it gives you everything in a one single platform where earlier what industry used to do and customer used to do for the switching, they are taking Cisco implementation. For the router, they might be using Arista router, for example. For the load balancer, they might be using F5 load balancer. For security, they might be using Palo Alto. For monitoring, they might be using some monitoring third-party solution, which are very good in the giving you intelligent dashboards. So they might be using some third-party vendor solution just for monitoring this stuff, right? Or maybe they might be using the dedicated UI, which is provided by every single vendor. Data secure VPN, they might be using some third-party vendor devices for the VPN, right? So this is the complexity. But now NSX gives you everything in a one single platform. So you don't need to deal with this heterogeneity. So that's what pretty much NSX is all about it, right? And that's what NSX gives you. So when you really understand the NSX data center use cases, these are the three major use cases of NSXT data center where you have automation, security, and application continuity. So NSX is actually gives you these use cases where you can automate the entire IT. You can actually give you the micro segmentation where it gives you the firewall which you can apply at every virtual machine level. And it also gives you disaster recovery kind of solution like SRM, cloud disaster recovery solutions, hybrid cloud networking. Everything really got simplified with this NSXT data centers, NSX data center solution. Because this conclude our discussion about why NSX, where we have understood some of the key challenges of traditional physical networking. And we understand that how NSX addresses all those challenges. We also understand what exactly NSX solution is all about it and what are the key use cases of NSX solution. If you are preparing for NSXT L3 admin, NSXT consultant, NSXT domain expert, or NSXT solution engineer kind of profile, or if you are struggling to crack NSX interviews and want to prepare for NSXT interviews for better career growth and career opportunities, or if you are preparing for VCP-NV or VCIX-NV kind of advanced certification, then we would strongly recommend you to join GoVMlab VMware NSX-T Zero to Hero Deep Dive program. Now, this is a very uniquely curated in-depth learning program about NSX-T networking and security capabilities. This program have received five-star rating from a lot of our careers. What This program have received five-star rating from a lot of our learners, and none of our learners have ever failed in NSXT interviews. And with this
in-depth learning program, they have been successfully transitioned their career into VMware NSX-T technology with the Zero to Hero Deep Dive program provided by GoVMlab. Now, here are the key highlights of this program. As you could see that it's 80 plus hours of intense learning program. We do provide 45 plus of hands-on lab to understand NSX networking security feature and its key capabilities. It will also help you to prepare yourself for not only VCP NV, but also help you to prepare for VCIX NV kind of advanced certification. Our mentors are having an industry experience of more than 15 years, and there are mentors who are having more than 10 years of experience on NSX technology, and they do hold all of the NSX certification. At GoVMlab, you also get flexibility to have one-on-one in-person doubt clarification session with our NSX mentor, and this program certainly going to help you for preparing for NSX job interviews as well. Now here we have captured some of the feedback from our learners. You can check out these feedbacks on our LinkedIn page, and as you could see that we have received 5-star rating from all of the advanced. We have received a very good reviews and feedback from our learners. Now we do have captured some of the feedback from our learners for your reference. If you want to check it out, you can check out our LinkedIn page and you can find all of the learners reviews and what are they talking about GoVMlab NSXT 0 to Hero deep dive program, as you could see that. And here we do have captured some of the feedback what we have received from our learners on our personal WhatsApp chat as well. So what are you waiting for? If you are looking for a very in-depth detailed learning program about VMware NSXT technology and you do have a passion to become VMware NSXT expert, then reach out to us on this given phone number. You can also drop us email on the given email ID, or you can browse our website as well. So reach out to GoVMlab team and transition your reach out to GoVMlab. So what are you waiting for? Start your journey with GoVMlab. So what are you waiting for? Start your NSXT journey with GoVMlab today itself. Thank you.